Okay, so here we are back on the mean green. It's been a few weeks because I've been away on the boat and done other things. So we have a working synthesizer with all working controls, and now we want to be able to save super duper sounds. And to that end I have got a little module which has a W25Q XX chip on, and the XX is the size, and I don't know which size it is because I haven't taken it out of the bag and looked at the chip yet. SPI flash memory, which we are going to use to store our programs. So first thing, I guess we need to connect this to that. Okay, so we have here a WinBond flash memory chip, and this, I still haven't taken it out of the packet, so I still don't know what size it is, but it'll be big enough. It's megabytes. And this is a standard SPI interface to the Nucleo. It's also 3.3 volts, so it should be easy enough to wire up. But before we can do that, we need to allocate an SPI interface. So we look on the Cube MX. So SPI1 we can't have because there are various conflicts on pins, and SPI2 we want full duplex master, so there are conflicts on pins there. So I am probably going to have to rewire some of the existing connections to let me get at one of the SPIs, and then rejig the code for the rewiring. So I think the first thing to do is to figure out what I'm going to have to rewire and rewire it. Okay, so SPI2 needs pins port B12, B13 and B14. It takes over those pins, and those, if we look here, were control lines for the display, so I have moved those to B1, B10 and C5, which were otherwise unused, and I have done the soldering. So here we want to generate code. Okay, and here's the project, and you can see the defines for these lines are now B3, B10 and C5. So if I ask it to recompile all that, it will recompile absolutely everything because I've changed the CubeMX project. Okay, so I have the wiring done, persuaded the code to recompile at the fight. So if I power it up again, the display doesn't happen, but that's what we would expect. So if I now go back into here and upload the code and start her up, the display doesn't work because I have unplugged the display wires and not replugged them in again. Okay. Are these little guys? Okay, so with those in, I plug that back in and it may actually work. Nope. Right, I have some fixing and debugging to do. Okay, so fiddled around with it all, fired it up, rewired it, and just got a nasty noise out of it. Done something wrong, so reverted to the old one here from the backup and started again, changing things slowly. So now we are in the position where it all still works, but the display is unplugged wherever the display wires are. So let's first up power this back up again. That's good. The synth still works. Just move some stuff out of there, and the display doesn't, so I guess we need to now go in and find out what I've done to upset the display. Okay, so I discovered my problem. The 8 data lines to the display are on port C, and as you can see here, I write to them as a whole port, GPIO port write, not a single line write, and that overwrites my enable line control. And I could have put some code into here to make sure that wrote the enable line as well, but who's to say that wouldn't have had problems and the other code works. So what I did was I moved the line from C5 to B0, which unfortunately wasn't next door on the Nucleo, but I did it, and that needs to be taken off. Now, how should we do that? No, come on. Reset state. Come on. And if we go over to the mean green and turn her on, we have a display, and there. It works. So that is that done. So now we have these 3 wires, that's one of them there going nowhere at all, which we can connect to the SPI chip, which I will now do. And we can finally, because it's taken me about a day and a half to get this far, get this going. Okay, so here it is, all wired in. And it's even got a little LED on it to tell you it's operating. Put a pull up on the chip select as suggested in the data sheet, so it's wired to cross here for the data and clock pin, and this on wire over here going to the other side is the chip select. So shall we see if it works? Okay, so here's a little bit of code just to test it. It's just looking for the device ID, asking for the device ID. Well, this is a generic piece of code where you send it a 1-byte command and you can get a reply back of however many bytes it's expecting. So we set the chip select low, we transmit the command of 1 byte, we receive the reply, and we set the chip select high. So shall we see how it performs? Go. And there we go, we get the ID, which is EF4016, and I've even got the camera pointing at the right angle so it'll see the display. So if we go back to here and look at that, okay, EF, yes, is a manufacturer ID we would expect, and we send it the command 9F and we get 4016, so it's a 32 meg device. All good. So now we can go on and write some proper code to load and save programs. Okay, so I have implemented the menu system properly, so we can actually get at it from the menu buttons, not just from operating one of the controls. So there we go. Let's go down to the oscillator menu. Into the oscillator menu we can change a value, and we can go back to the main menu, into the envelope menu, again change a value, and then back to the welcome screen, and so on. So now I can add at the top of these menus a load menu and a save menu, and I'll also add a MIDI menu, and possibly a joystick menu for when I get onto that. But for now we're just interested in implementing the load menu and the save menu. Okay, for those of you who don't know, let's have a quick look at how flash memory works. This is our flash memory. In flash memory you can read anywhere, you can read randomly, but writing is something different. You can only actually write zeros. So to rewrite anything to flash, you have to first erase it to all ones, that's the bits in the flash, and then write to it. And to complicate things, you've got to write a page at a time. Now the chip is clever, and if you write half a page it will load the page, modify the bit you want to change, and write it. But what I've chosen to do is basically make each block of memory a whole number of pages and just write pages. Okay, and these chips have 4K sectors that I call blocks throughout the code. So I decided basically to do it simply and use one program per 4K sector. So if we want to save a program, just erase one sector and write it. This is a bit inefficient since the programs are only about 800 bytes, but I'm going for quick and easy here. Okay, so I have sort of consciously decided to go in a rather MIDI way of working. So if it ends up the way it looks and feels in a kind of rather 90s synth, then that is why. Just for speed and ease of getting it running. So it has 128 programs accessed by number. I originally thought of using a filing system and just having some files for the programs, but this way is quicker. So the program is stored as a series of text IDs and numbers, apart from the first one, which is the name of the program. Here I've called it triplicate sound, just for, well, just have. So there's filter config, which is filter config, filter cutoff modulation amount, filter cutoff modulation sort, resonance, etc, etc. You get the idea. This is, I suppose, quite a memory heavy way of storing it, but got lots of memory. It only comes out at 800 bytes and we're using 4K per program, so it's not a problem. And it has the advantage that we can add extra parameters. This can be in any order, and we can add extra parameters. We could have a, I don't know, let's call it fuzz lev 35. So if the synthesizer read this program and had never heard of fuzzlev, it would ignore it. And if we had an old program that didn't have a fuzzlev setting included, there will be a default fuzzlev, probably 0, in the default program. So that's that. So in the end, controlling the chip is quite easy using the HAL. So to read, we set the chip select pin low. We transmit the command, which is 1 byte of the read command and 4 bytes of the 3 bytes, should I say, of the read address. So that is, it transmits 4 bytes and then it receives as many bytes as it's expecting to receive, and sets the chip select high. The write I've split into two, so it sets the chip select slow, writes the write command and the 3 byte address, and then writes what is always in my case 1 page 256 bytes of data. The only extra thing you need to know with the write is that, okay, also with the write, which I suppose should have gone in there, you have to set a command, a write enable command, which is just 1 byte. You send it 1 byte, which is 6, and that enables the write. If you don't send that, the write doesn't happen. And if you forget to send it, you can scratch your head for some considerable while before you realise what's the problem. And before you write, you have to call the sector arrays again with the address to set it all back to F. Again, if you try to write to a sector that's not to a sector that's not erased, you get some weird results. So again, you have to send the write enable, and then you send command 20 to the address, just the 4 bytes. You send it out, and off it goes. And as you might be gathering, there are lots of pitfalls here for strange things to happen, especially as you're trying to write. I'm trying to write and then read back, and I don't know what's in the chip, or whether it's my write that's wrong or my read that's wrong. So it took me some while to get it working, just mostly for silly little things. So what else? Yeah, we'll go back to here. Right, I've used the HAL SPI transmit and HAL SPI receive functions. They are blocking functions. That is, until they're done, they don't come back. That's it. You can't do anything else. The code just sits in them. So I haven't tried it yet, but I will. If you try and save if I try and save a program while there's a note playing, it'll probably glitch. So to stop that, we could either use interrupts, transmitting on the transmit and receive, or the DMA. But that will be a load more hassle, having to queue things up and getting an interrupt and then send some more and getting in. So I decided in the end, unless it becomes a problem, load and save programs while notes aren't playing, as a first hit to get us going. Okay, so let's fire it up. Plug it in off the power supply so it doesn't hum so badly. There we go, and you can see I have changed the startup screen, the screen that's on when a menu isn't been displayed, so it tells you program 0 is currently selected, and that's called default program 0. That's just the name I have assigned it. So we can go into menus, and it comes up in load menu. That, for what it's worth, is the cursor. Go into load menu. So it says the new program is 7, and that's what the default program 7 is, the name of the program. And if we want that one, we just hit that loaded program. Now if we come out of the menu It says loaded program 7. So one thing we can do, we have now a Prog name menu, and this really is a bit clunky. So there's the cursor, and you can change the letter with the cursor. You can also use that, which is just a little bit faster, and then you can select on for the next letter. Keb. Kebab. Oh, come on. Kebab program. So that's what we've called it. So now if we come back out of there and back out of the menus, kebab program. Oh, where's that come from? I am not saying this is completely without bugs. However, right, there we go. So now we can save this, and no, save menu. I did say it was looking a bit like a 90s synth. Well, this is a sort of 90s display, or maybe a bit later, which adds to the 90s feel. And I know the menus are clunky and ugly and horrible, but I am at the stage of just wanting to get the thing running. So they'll have to do for now. So we can now select, we can save it to program 7, and the name is what it was. Okay. So there's a bug. Well, we'll see what happens. We'll see what happens. So if we select, oh, and now it says the right number. Okay, there's a bug there. I will find them and fix them. So let's save it to program 30. That's the, that's the name that's in the program that's already in memory. So if I do that, kebab program save, it's saved to 29. Should that be right? Anyway, $29 is kebab program 7. Saved it to 20. And if we go down to seven is kebab program 7, and if we load that and come back out of the menu, there we go. So it works. As I say, I'm not sure it works 100%, but I will find them and fix them. And I was going to see if it glitched while it loaded a program, but I've plugged it all in, fired it up, and it's clicking somehow. I don't know whether that is a software or a hardware or a wiring fault, but I think I will put fixing that onto the next video and wrap this one up here. Right, I am going to call it a day for this video. Got where I wanted to be. I'm aware that I've actually written an awful lot of code and spent an awful lot of time doing it to get here, and it doesn't make for particularly interesting video material. However, we have one more, I guess, session of intense code writing to do, which will get the MIDI working. Currently only the note on and note off work, and we'll get the joystick working and fix that wretched crackle which has crept in from somewhere. And at that point we will be ready to actually start. Well, I'm going to actually try and compose some music with it, see how it goes, see what it sounds like, and out of that I'm hoping we will come up with some ideas to improve it. And there already are some improvements to the filter which I've shown in the tutorial videos, which aren't in here, so we'll try those as well. And hopefully at that point it'll all get a bit more exciting and interesting, and a little less me slogging along and writing code. So for now that's it. So it's goodbye from Triplicate, home of interesting electronics. Goodbye.